What if the future of humanity isn't on Earth at all? Imagine entire cities floating in space. Massive rotating cylinders where millions of people live, work, and raise families under artificial skies. It sounds like science fiction, but serious scientists and engineers have already designed them. In this video, we'll explore why floating space cylinders could become humanity's next home, how they would work, and why some experts believe this is more realistic than colonizing Mars. What exactly is an O'Neill cylinder? In 1976, a Princeton physicist named Gerard K. O'Neill published a book called The High Frontier. In it, he proposed building enormous cylindrical space habitats, each one roughly 8 kilometers wide and 32 kilometers long. That's bigger than many cities. The idea was simple but mind-blowing. Instead of terraforming a planet, which takes thousands of years and may never work, you build your own world from scratch and design it exactly the way you want. Inside the cylinder, you get land, water, plants, breathable air, and a full weather system. The whole thing spins slowly, and that spin creates artificial gravity. Walk around inside it, and you'd feel completely normal. Feet on the ground, objects falling when you drop them, no floating. NASA studied this concept seriously in the 1970s and concluded it was technically feasible. The barrier was never physics. It was cost and political will. And both of those things are rapidly changing. How does the gravity work? You don't need a planet's mass to create gravity. You just need rotation. When the cylinder spins, everything inside gets pushed outward toward the inner walls. That push feels exactly like gravity pulling you down. Engineers call it centripetal force, but to the person living inside, it just feels like standing on solid ground. The key is getting the spin speed right. Too fast, and you feel sick and disoriented. Too slow, and things feel weirdly light. For a cylinder the size O'Neill proposed, about 2 rotations per minute creates Earth-like gravity of 9.8 meters per second squared. Here's the bonus. As you move toward the center of the cylinder, the axis, gravity weakens. Right at the core, there's almost zero gravity. Designers have imagined using that central zone for sports, recreation, or even personal flight with strap-on wings. So in a single structure, you'd have 2 completely different gravity environments available to you. What does life inside actually look like? Picture waking up in a house with a garden. You step outside and look up. Instead of sky, you see more land curving overhead, towns and forests wrapping around the inside of the cylinder. The sun doesn't rise or set like on Earth. Giant mirror panels outside reflect sunlight through long windows running the cylinder's length. Tilt those mirrors, and you control day, night, and seasons. The air is sealed inside. Rain cycles, clouds, and humidity all engineered and controllable. You'd have farmland, residential areas, forests, lakes, and rivers. Temperature, wind, and rainfall are dialed in precisely. No unexpected floods, no droughts, no hurricanes. O'Neill himself imagined these habitats as genuinely beautiful, more like rolling countryside than a tin can in space. A single large cylinder would offer hundreds of square kilometers of livable land, enough for millions of people. Why Jeff Bezos is all in. Jeff Bezos doesn't just like O'Neill's cylinders, he's obsessed with them. He said publicly, multiple times, that this is humanity's correct long-term future. His space company Blue Origin is actively working toward this goal. Bezos's argument is simple. Earth has limits, fixed land, fixed resources, and a ceiling on how much energy we can use before the planet overheats. His answer is to move heavy industry off Earth entirely. In space, the sun shines 24 hours a day with no atmosphere blocking it. You generate massive solar power, build factories in orbit, mine asteroids for materials, and let Earth become a nature reserve, protected and beautiful. In Bezos's long-term vision, Trillions of humans live in O'Neill habitats scattered across the solar system. A growing number of aerospace engineers and space economists agree. Permanent off-world living in artificial habitats, not on planetary surfaces like Mars, is the most realistic path forward for our species. Where does the building material come from? This is the question that stops most people cold. An O'Neill cylinder needs millions of tons of material. You can't launch all of that from Earth. Lifting mass out of our gravity well is incredibly expensive. That's why the plan always assumed off-Earth mining. The Moon is the top candidate. It has silicon, aluminum, iron, and construction material right on the surface, with low gravity and no atmosphere to fight. Launching from the Moon to orbit costs a fraction of what it costs from Earth. O'Neill himself suggested electromagnetic rail launchers, mass drivers, to fling raw lunar material into space for collection and processing. Asteroids are the other major source. Some near-Earth asteroids contain more mineral wealth than all of recorded human history of mining. In a single floating rock, capture one, process it in orbit, and you have enough material to build enormous structures without touching Earth at all. The technology to do this is still early, but actively being developed. The real challenges, let's be honest. Building one of these is incredibly hard. The structure must stay airtight over massive surface area, handle constant rotational stress without failing, and shield against the high-energy radiation that fills space. That shielding alone adds enormous mass to the design, making construction and launch logistics a monumental challenge. Then there's the human side. Living in a closed engineered system, even a large, carefully designed, and beautiful one, is psychologically very different from life on Earth. You would constantly be aware that you're inside a machine, completely dependent on engineered systems for air, water, food, and energy. A failure in any core system isn't something you simply recover from. It could cascade into catastrophic consequences. Beyond engineering, the social and cultural challenges are just as daunting. Who owns the cylinder? Who governs it? How do you resolve disputes when millions of people fundamentally disagree on priorities or values? What rules, laws, and social norms would even make sense in such an environment? These questions demand entirely new frameworks in law, politics, economics, and social design. Building the structure is only half the challenge. Keeping it functional, livable, and equitable over decades or centuries may be the greater one. When could this actually happen? Not next year, probably not next decade, but the groundwork is being laid faster than ever. SpaceX has slashed launch costs. Blue Origin is building heavy lift rockets and space infrastructure. Multiple companies are racing to put commercial stations in orbit. NASA is funding in-space manufacturing. Private firms are pursuing asteroid mining. Most serious researchers talk about prototype habitats in orbit by the 2030s, experimental colonies by the 2040s or 2050s, and city-scale O'Neill habitats in the second half of this century. That's a long timeline, but not a fantasy. It's an engineering problem with a known solution and better tools arriving every year. 60 years ago, no human had left Earth's atmosphere. Today we have a permanent space station, reusable rockets, and rovers on Mars. If that pace continues, the question isn't whether O'Neill cylinders will be built. It's who builds the first one. The future of civilization might not be on land or sea, but in orbit. If this expanded your imagination, hit like and subscribe for more mind-bending ideas about humanity's future. And watch the next video to see which space projects are closer to reality than you think.